Good afternoon, students. I welcome you all to my online class on dynamics. So today we are going to solve the remaining two problems based on components of velocity and acceleration along tangential and normal direction. So let's solve the next problem. Just to see the statement of the problem. A point moves in a plane in such a manner that the normal and tangential accelerations are always equal, and the velocity varies as e to the power 10 inverse s by c, s being the length of the arc measured from a fixed point of the path, and c is a constant. Find the path. So here what is given? The normal and tangential components of accelerations are equal, and beside this velocities varies as e to the power 10 inverse s by c. So just to see how to start, according to question, you know that velocity is proportional to e to the power 10 inverse s by c. So from this v we can write it is k e to the power 10 inverse s by c, where k is a constant. Again, the components of normal and tangential accelerations are equal, so we can write v dot is the tangential components of acceleration, which is equal to v square by rho is the normal components of acceleration. So these two are equal. Now v dot we can write say dv by dt, and v square by rho is possible to express v square d psi by ds, because 1 by rho is the radius of curvature. So radius of curvature we can write it is d psi by ds. Now dv by dt, by chain rule of differentiation, we can express this way. It is dv by ds is equal to what? Dv by ds into ds by dt, and this side you keep as it is v square d psi by ds. So this equation is possible to solve by the method of separation of variables. So if you simplify this one, ds by dt we can write v dv by ds, and here v square d psi by ds. So by eliminating the similar terms, or eliminating the similar things from this so that it should be integrable, we can write as, just to see, we can write as dv is equal to v d psi. So this we can express dv by v so that it should be integrable is equal to d of psi. So integrate dv by v. So if you integrate dv by v, what you will get? Log of v, and integration of d psi you will get psi. With that you will get the constant of integration. So I have written the constant of integration as log of a. So now just simplify this equation. Log of a you bring to your left hand side. So if you apply the laws of logarithm, you will get log of v by a is equal to psi. So from logarithmic form you write down the exponential form. So here log, it is the natural logarithm, and the base of this logarithm is e. So if you write down the exponential form, v by a, we can write e to the power psi. So from this, the expression for v, we can write a e to the power psi. And what is the expression for v? Because v is proportional to what? E to the power 10 inverse s by c. And so from that we can write v is equal to what? It is k times of e to the power 10 inverse s by c, where k is a constant. Right hand side we have a e to the power psi. So e to the power 10 inverse s by c, we can write a by k e to the power psi. A by k is a constant, so in order to simplify this expression, a by k we can write e to the power alpha. E to the power alpha is equal to what? It is a by k. So that by comparing both sides we will get the expression for 10 inverse s by c. So if I write a by k is e to the power alpha, so here base is same. So if base same, you know the if base same, we can add the power. So what you will get? E to the power 10 inverse s by c is equal to what? This e to the power alpha plus psi. So from this you will get 10 inverse s by c is equal to what? It is alpha plus psi, and this expression is the required equation of the path. Okay, now let's come to the last problem. Prove that if the tangential and normal acceleration of a particle describing a plane curve be constant throughout the motion, the angle psi through which the direction of motion turns in time t is given by psi is equal to a log of 1 plus bt. So here a and b are constant. So here it is given the components of tangential and normal accelerations, they are constant. So with the help of that we have to show that the angle psi psi which turn in the direction of motion in time t is given by what? Psi is equal to a log of 1 plus bt. So we can start this way. So what is given, or we can say according to question, tangential and normal components of velocity are constant. So we can write tangential components of acceleration is v dot. We have it's constant, so we have written lambda. Lambda is a constant. And normal components of acceleration is v square by rho. This is also constant. We have written mu. So here lambda and mu are what? They are constants. Okay. Now from equation 1, v dot we can write dv by dt is equal to lambda. So if you cross multiply, so what will get? dv is equal to lambda dt. So if you integrate this one, v, you will get vt plus c, where c is the constant of integration. Now from equation 2, see v square we can write mu rho. Rho is what? ds by dc, because 1 by rho is the radius of curvature. So if so from that you will get rho is the expression for rho will be what? ds by dc. So this v square we can write v ds by dt, because this v you keep as it is, and for v we can write rate of change of the arc, so it is ds by dt. Now write down the expression for v. What is the expression for v? It is lambda t plus c. So in place of v you write this expression. So this equation also we can solve by the method of separation of variables. So if you simplify, you will get d of psi. D of psi is equal to what? It is mu dt by lambda t plus c. So if you integrate this one, what is the integration of d of psi? The integration of d of psi you will get psi, and this side if you integrate this one, mu is constant, lambda, if you take the method of substitution, lambda will come outside, so you will get log of lambda t plus c plus k. Here k is a constant. So now we have to find out the value of this constant k. So how to find out? Suppose psi is equal to 0 when t is equal to 0. If we impose this condition, then it is possible to get the value of the constant k. So psi is equal to 0. So take psi is equal to 0 and t is equal to 0. So from that you will get the expression for k is equal to what? It is minus mu by lambda log of c. So substitute the value of k in this equation, you will get the expression for psi. So see here. So psi is equal to what? It is mu by lambda log of lambda t plus c, then minus log of c. So simplify by the laws of logarithm. It is log of lambda t plus c by c. So lambda t by c you can separate this way, and c by c is equal to 1. So from this mu by lambda is a constant, so that one we have denoted by a, and here lambda by c is also constant, that one we have denoted by b. So from that you will get psi is equal to what? It is a log of 1 plus b of t. So this way we can show that the angle side turns in the direction of motion, and the expression for psi is equal to what? It is a log 1 plus b of t. Hope that both the problems are clear. So in next class we are going to start with a new topic, simple harmonic motion. Thank you.